Hello, this is our Week 8 Object-Oriented Programming presentation. BID programmers base their design upon the model, view, control pattern. MVC separates and organizes the design of the classes in the system into 3 layers. Each layer is responsible for a specific part of the functionality of the program. The view layer consists of those classes that are responsible for the end user interface of the program. A view class retrieves the inputs entered by the end user. They determine the action to be performed and display the output to the end user. The control layer consists of those classes that are responsible for the actions or behavior of the program. These classes contain methods that perform the calculations, make decisions, and send and retrieve data to and from the objects in the model layer. The model layer classes are responsible for storing the data associated with the logical or physical things, like the game, player, map, location, or resource in the program. These types of objects are normally saved in a database or a file.
The control layer class consists of classes that are responsible for the actions that control the behavior of the program. These classes contain the methods and commands that get executed as a result of some action taken by the end user in an end user story. Control methods typically are responsible for the actions to be performed in the game. These methods are responsible for performing calculations, making any decisions, retrieving and updating data stored in the model layer classes. Now, it's a smart move as designers to create a control layer class for each group of end user stories that are logically related to each other. This helps to keep things organized and make sure that your code is together and that it's easy to keep track of and go through.
Now, defining the control methods. Each method added to a class should perform only a single task and theme. This helps your code be more modular, durable, easy to change, and debug. You should be able to describe the task performed by the method in a single declarative phrase. For example, if you look at the set offering method that I created, we are trying to find the percentage of the harvest that is to be paid as an offering. It only gets the percentage of the harvest that the player wants to pay. It does not do any calculating. To know the actual payment of the offerings, see Pay Offerings. We will be discussing how to develop a method, and we will walk you through and demonstrate the 7 steps of process used to design and develop that method.
All right, so there are 7 steps on how to develop a method. Step 1 is to clearly define the problem. 2, to create the test matrix. 3, outline the solution. 4, test the algorithm. 5, translate the algorithm into code. 6, run the test cases to verify that the code is working as specified. Step 7, deploy the changes to the repository.
Now, looking at the buy land method, we can go through these steps. First, we will clearly define our problem. We are trying to buy land. The parameters are the price of the land, the number of acres to buy, and the reference to a crop data object, which is bushels of wheat. The amount of land after the sale will be the return. The number of acres to be bought must be positive and less than or equal to the number of acres bought. We can identify the purpose, parameters, returns, and preconditions. The best way to do this is with the method prologue. It goes in front of the code for the method. Next, we will add in the method signature. It tells us the name of the method and what its parameters are, and what kind of data the method returns. The second step in the development process above is to create the test matrix. This test matrix dictates what the method should do. It is used to test your algorithm and your code.
All right, so here we have the test matrix we created for the buy land method. So first thing we need to do is create a formula. to properly test and to create the formula for buying the land. So here's that formula. We have the Wheaton store is equal to Wheaton store minus acres to buy times the land price. So first thing, we need to create a scenario where it was valid and would work 100% of the time. That would be correct, and that would be Wheaton store is equal to Wheaton store minus acres to buy times land price, and that the one we chose to use is 1,500 minus 50 times 20. That would give us a value of 500 Wheaton store remaining, and that one is valid. So then we need to create some invalid ones. So the first one we decided to go with is we need to buy 100 acres with 30 bushels each as the price, and we have 1,500 Wheaton store. So we have 1,500 minus 3,000. That is invalid. Next, we have -5 acres to buy. Well, you can go ahead and stop right there. We cannot buy negative acres, so that will return a -1. And then we have 200 acres to buy at -10 as the price. We can have negative land price, so that'll return -1. To test the boundary, the absolute lowest we can go, we have 200 acres to buy with 10 bushels as the price, which would give us 2,000. 2,000 minus 2,000 would equal 0. All right, so now that we have created the test matrix for that, we need to go ahead and write it into the code here. And so writing the code here, we have the method signature right there, and the pseudocode is in comments above every bit of code we need. And so starting from the top, we have the acres to buy less than 0. If the acres to buy is less than 0, we need to return -1. So writing that in, if the acres to buy is less than 0, we return -1, and if it's not, we keep going. The acres to buy times land price, if that is greater than the Wheaton store, we need to return -1. And if it is true, then we'll move on to the acres owned equals acres owned plus acres to buy. So we'll do that, and that'll store the data. And then we move to Wheaton store. Our formula that we used equals Wheaton store minus acres to buy times land price. And it'll store that data. And if all the conditions previous before are true, then it will return the acres owned at the end.
Now that it's all written out, we need to test the code. This is important, especially when you have equations. A test can help with any issues that you have with your code. It can help you identify if there's anything that might be missing, or if it is adding things up wrong or multiplying wrong, just to make sure that those equations that you have are correct. So what we have here is we've written our test code out. We've put in the integers just from our test matrix that we had that we'll go through, and we'll run through one of these for each of those. Do one for the one that's going to work, 3 of them that won't work, and then the border, just to make sure that all of our stuff is written correctly. And this helps you narrow down any issues where your code might be as far as any of those equations, anything you have with equations, and you're able to get those done right then and there, and get them resolved so that they match up.
We will now talk about the selection statements that we found in our code. In Java, if is a conditional statement. It will provide execution of one of 2 statements or blocks, depending on the condition. Now, if we look at the syntax, here we have my setOffering method. If the condition is true, then the statements inside the if block will be executed. The execution will be continued to the next statements after the execution of the statement in the if block. If the condition is false, then the statement inside the if block will not be executed, and the execution will start from the statements that are next to the if block.
Now we have another example of an if statement. These if statements right here is to make sure that there's enough wheat in the store to cover what's needed to pay for the land. If there's no wheat, it'll give you an error. If there's not enough wheat, it'll also give you an error. So it goes through and it says if wheat in store is less than 0, well, that means you have a negative. You can't buy anything if you're doing that, or you can't feed people if you're doing that, and it will return an error. If the wheat for food or the demand for the food is higher than what's in the store, it will also return a -1. If it meets both of those, it will then go through and return what has been set as the wheat in store for that equation.
All right, next we have a switch selection statement. So here we have an example from our main menu view. So a switch statement is used, unlike an if statement. The switch statement can have a number of possible execution paths. So for this example, we have 5 possible execution paths depending on which one you choose. You can either create or start a new game, get and start a saved game, get the help menu, save a game, or quit the game. And if you choose an option that is not valid, it would just simply tell you to choose a valid option.
Now we'll talk about the scope and lifetime of variables. The scope of a variable defines where it can be referenced and used. The scope of the variable is confined to the block that the variable is defined within. We will look at the Help Menu View class to better demonstrate this. The Help Menu variable is defined in the class block and has class scope that can be used and referenced anywhere within the class. The user input variable is defined in the Get Menu option block. Its scope is only within this block, so it can only be used within this function of block. The user inputs a variable, and if it is a valid value, it will return the user input. If it is not valid, then the system will print out an error message to select 1 through 5. The lifespan of a variable dictates when a variable is active in memory and can be used. It starts when first defined and allocated in the memory. The Help Menu variable is defined in the Help Menu View block. Right here. It is allocated for this variable each time a new instance of the class is created. The user input variable is defined in the Get Menu option block. The memory is allocated for this variable when the function is called and the execution reaches the statement where the user input is defined. Now we can look at the if statements block. When the user inputs the variable and it is invalid, it will loop back to the top and display the error message. If it is valid, it will return the user input. A variable life ends when its execution reaches the end of the block that it is defined in the memory. Then the memory is freed. The memory for the user input is freed at the end of the function block. The Help Menu memory is freed when the object instance is destroyed and no longer used or referenced.
Now we're going to talk about passing parameters by value. When we call a function, we can pass the values by copying them through the function parameters when it is called. We use this to pass value when we are only using the parameter for some computation, not changing it for the client program. So this can be information that you're pulling for an equation. For example, we have wheat in store. Wheat in store equals the data.get wheat in store. So this can be used to pull that information to run an equation somewhere in the program. Now, we also have one for owned and wheat as well. We've seen our examples, and they all refer back to their prospective information, get acres owned and wheat in store. And this helps you to be able to use this information throughout the program without having to consistently write a big long equation. You can just refer back to that information there.
All right, next is passing parameters by reference. So passing object instances is different. That's why we pass by reference. We don't pass the object directly, we pass it by a reference to the memory or location of where it is stored. Use pass by reference when you are changing the parameter passed in by the client program. So here we will have an example of that. So this is from our public class game control. We create the game object and a player object, and these are then referenced in the public class City of Erin, where you see player equals new player and game equals new game. This has been our CIT260 Week 8 presentation. Thank you for watching.